Hi everyone, welcome to my lecture series on operating systems. So I have this question here. So operating systems is a name which I think more or less everyone would have heard. And if you are a computer science student or someone working in computer science, then definitely for us they are sort of everywhere. So what I'm not doing is comparing operating systems to God. That's not in any way true, but yes, they are everywhere around us in every device which we use. So talk about a mobile, a computer, a smartwatch, a smartphone, a washing machine. It's everywhere. And interestingly, just like God, operating system also come in different names, different forms with different properties. Right, so these are just few most popular operating systems which are listed here. So I've taken this from YouTube video from this channel. Data is beautiful. So anyways, the point is not to figure out which is the most popular operating system, but to see that there are actually a lot of operating systems, and which operating system you are using varies from device to device. So if it is laptop, it will mostly be Windows, Linux or Mac OS. If it's mobile, probably Android. And there are also operating systems for televisions, mobiles, watches and whatnot. What exactly is operating systems? So very controversially speaking, you can sort of say that operating system is the soul of any device, any smart device as such. So we will be specifically focusing on computers, and same things apply to other devices as well, which need some kind of smartness. They are like the soul of a system. So what does that mean? For us as human beings, we are not just our body, and there's like a whole lot of spiritual talk on this, but the point is we are something more than body, and once that something leaves our body, we actually are nothing more than a soil. So there is something inside this body which makes this body work, and we call that a soul. Similarly, with all that hardware a computer carries with it, the CPU, memory, transistors, flip-flops and whatnot, they alone are not sufficient. There has to be something which sits on top of that for it to work. As an example, if you purchase a computer from shop, definitely it will come with an operating system. Might be not, you can install your own operating system on top of it, but mostly it comes with an operating system. So the idea is this computer is just a box without an operating system. And you see, just like the human body, our brain can still brain is a part of body, right? And soul is something which even brings brain to life. So brain cannot work without soul. If a person dies, all those neurons and the brain, the physical brain, it's still present there. So same is the case with computers. They also have a brain. We can sort of say that the processor, CPU and memory, if they together form the brain of a computer, they are just the hardware part of it, and they alone cannot do it. Still you need a software to run on it, which is the operating system. This is what makes our computers work. So hardware definitely is a must, but the point is you need something on top of that hardware. More concretely talking, if you talk about operating system, since it's a software, it's all just lines of code, but billions of lines of code, a whole lot of lines of code which people have sort of created over this journey of 60 years. And when you talk about these lines of code, they are not any normal lines of code. It's not a Python code at all. Python is something which is so easy to use and hides a lot of details from you. When we are talking about these lines of code, we are talking about those programming languages which come very close to bare metal programming, something like an assembly language or even C or C++, not Python. Yes, technically speaking, you can write an operating system in Python, but not wholly. Still, there has to be parts of it which you'll have to write in low-level languages. Even maybe some part of it should be assembly language or something else. So, as an example, if you write something like a equals to 10 in Python, it's actually hiding a whole lot of details from you. So, if you're someone new to programming, you might think that it's an integer which is given a value of 10, Well, actually not. So if you have studied object-oriented programming, when you do A equals to 10, a whole lot of things are happening. You're creating a class, you're creating an object, and this A, it's not even an object, it's pointed to an object. And what even am I talking about? To understand that, you'll have to take you have to take a class on these basic programming languages like C and C++. Well, so the point is, if you want to do certain programming which is like deep inside the computers and plays around with the hardware, then definitely languages like assembly language, C and C++ are a get-go. Talking about assembly level languages, there are top universities in the world which actually ensure that their students know how to code in assembly language. And definitely we can always look up these code and learn more about them. So it just reminds me of this particular TV show. If you can guess it, which is it? It's actually this Netflix show, Person of Interest. And what is so great about it? So if you look at the show, it actually centers around an all-knowing machine which can predict what's going to happen in advance. And if you have watched the series carefully, have you noticed in which programming language was the machine written? So in a few episodes, they sort of show a very small flash of the language in which it was written, and it was definitely a low-level language. And as far as I understood it, it was definitely C. So here is a machine which has to do a whole lot of talk to bare metal programming. This machine is so smart that it knows how to protect itself. So if it knows that in future there's going to be an attack on it, this machine could actually teleport itself to some other place with the help of electric wires. And in order to do that, you actually will have to use a programming language which comes very close to the hardware. And this might actually be mind-boggling for a lot of people. So where exactly is this thin line between the hardware and software? All we are saying is that your machine is a bare hardware, and then comes these lines of code, the so-called operating system. It sits on the top of that hardware and the hardware starts working. Well, how exactly is that happening? What is the thin line where the software sort of translates into hardware? If you have taken a basic course on computer architecture, digital logic design, circuits, I'm sure that you already have the answer. And that's sort of a prerequisite for this course. There are certain courses which are prerequisites, some things which you should already know, and you should have a good knowledge about hardware to understand operating systems better. But anyways, talking about that thin line, it's all in our mind. You see, every piece of code that you write, every letter, every alphabet, it's just sitting in at some form of electrical charge on your RAM or some sort of magnetic field on your solid state drive or hard disk. So actually there is no such boundary between software and hardware. It's just a way of thinking. And you'll understand that when you use more of the languages, which basic languages like assembly, C and C++, like they say, devil is in the details. So talking more about operating systems, some lines of code, but this software, these lines of codes, it's a package of software. It's like all time running on your computer. So the moment you switch your computer on, it's working. You do some work, it's still working, and you turn off your computer, that's probably the time it goes to sleep. But next time when you switch on your computer, it again comes back to life. You can actually not do anything without this software. That's obvious, right? If I turn on a computer, something should happen. I should see an interface to which I can speak, and all the speaking is also mostly done with the help of operating systems. So it helps me run programs. If there is no cursor, if there are no icons, I cannot run programs. But not only it helps you in running the programs, it also helps you with a lot of other things. It ensures that your system is in a good state all the time. If it was not there, you would actually mess up badly. So a very good example of this is segmentation fault, which most of us get when we are playing around with pointers in C and C++. And well, segmentation fault is actually a nice thing. Well, what a nice thing. So most of the times we become worried when we look at segmentation fault. It's a nice thing in the sense that just like fever, is it a nice thing? No one will say that fever is a nice thing, but ask a biologist, he'll say, well, yes, it's a nice thing. It turns on the protection system of your body. It turns on your immune system. Same is the case with segmentation fault. If your operating system, it's the operating system in the background which is giving you a segmentation fault, well, if it wouldn't have done that, you would have actually made a change to some arbitrary memory location in your system and your system might crash. So it's saving your system from crashing. So that way it's a blessing in disguise. So there are a whole lot of things these operating systems are doing in the background. So it's just that how a biologist, he or she should know about your digestive system, respiratory system, excretory system, whatsoever. In the same way, anyone who is related to computer science, in my humble opinion, should have a good knowledge about operating systems. So from the next video onwards, we'll more technically and formally look into these operating systems.